Hey guys, Rudi here with another CSSE1001 tutorial for Python. This week we're going to be looking at class inheritance and extending classes in the week 8 tutorial specifically. But let's just get into what inheritance is, right? So last week we spent all this time talking about what a class is, how we can create these custom objects for us to use later on, and how it's really just like a really good way of setting up of designing some software that we need to write. And so now what we can do is we can actually extend on those classes, right? So I'm actually just going to go through this with an example. So let's say I'm making a game, right? A really basic game, and I've got this player class here. So the player can do a couple of things. Let's actually just get this set up. Let's make one. Fred is a player. Now if we look over here in the inner method, all we need is a name, because self is passed. Okay, so we got Fred. Cool, we got some unreadable stuff there, but that's awesome. So Fred is our player. Now what can Fred do? Fred can move in a direction, and Fred can attack a monster. So Fred.move north. Fred moves north, cool. And Fred can attack a terrible beastie. And Fred attacks terrible beastie. Cool. So this is a basic class, right? So maybe for every kind of player we have in our game, we want them to be able to move, and we want them to be able to just have a normal attack on a monster, right? But let's say we want to go a bit further than that. Maybe we want to have different kinds of players, right? So what we can do is, let's say we want to have an archer, like a bow and arrow archer or something. Let's write a class archer. Now an archer isn't an object, right? Or yeah, he is an object, but we can do better than that. We can say an archer is a type of player, right? So at this point here, the archer is now inheriting from the player, right? The archer is a type of player, it's extending player, however you want to think about it. And an archer, let's just give him one extra thing. He can shoot an arrow, right? Because he's an archer. Oops, he can shoot an arrow, and he's gonna shoot it at the monster. So let's just print so self.name to get our name out, right? Actually, I'm going to explain that in a second. I'm just going to finish writing this. Moves, no, not moves. What's he going to do? He is going to shoot an arrow at the monster. They might look at this and go, oh, cool, we got the self_name. I don't see that anywhere. What's happening here? Okay, so let's have a think about this. So archer is inheriting from player. Okay, so when we inherit, by default, everything in here is in here. Right? So everything in the player is inside the archer. So even though we haven't specified an init method for our archer, when we make our archer, we need to make them as if they were a player, right? So we're going to call their init method, because the archer doesn't necessarily have its own specific method, right? It's just, oh, cool, it's a player, but it can also do this one extra thing. So let's go over here and make George a archer. Okay, notice we're going to pass in George. Oop, name archer is not oh, I didn't restart my shell. Oops. Cool, there we go. And now we've got George. Okay, so everything in the archer is inside the player, right? So if we go to George, we should be able to call attack. Cool, George attacks a terrible beastie. So what happened there? We called archer. George is an archer. Now we called his .attack method. There's no attack method in here. So Python goes, okay, cool, let's go a bit higher and see what happens. Player? Cool, let's go into player. Oh, cool, there's a .attack method, right? And it calls the code from here. So in this case, we have an archer, we have an extended class, a subclass, if you will, that has everything about a player and just one little extra thing that we don't want all players to have, but just this kind of player. Okay, so that's just about extending to just add an extra method. Now let's add some more classes to our game here. So maybe we want to have an archer, and maybe we also want to have a ninja. Let's chuck a ninja in. Ninjas are cool. Kids like ninjas, right? Okay, so what's going to be different about this ninja? Let's say the ninja doesn't move normally. He doesn't move like the normal players. He moves all sneaky like, because he's a ninja, right? So we're going to change the way the ninjas move. Okay, Now this is called overriding. So see, as before, when we went over here and we tried to call .move or .attack from the archer, it went up to here, right? Because it went, do I have a .attack? No. Then it goes higher, okay? So now if we have a ninja and we write a move method and we call the ninja.move, instead of defaulting back up to the player class to call move, or to call it, yeah, or to call move, it comes down over here and we actually override that method. So let's do something slightly different in here. Oops. So he's gonna move in the direction, but he's gonna move all sneaky like a ninja. Okay, so let's make another ninja. Friend George, I'm out of twin names. Oh boy, Ed. Ed is a ninja. Name Ed. Okay, so just to prove once again that we have everything that's in here, we've got ed.attack. Beastie. Cool. We've still got the attack method coming from the player, but now let's try moves, or move it was. Yep. So ed move north. Ed moves north, all sneaky like, right? So we can see that it hasn't called the player move. We've actually overridden that, and it's calling the ninja's specific move. Okay. So this is overriding, and it's one of the important things that we do when we extend a class, right? Because sometimes we extend a class, and we can do both of these things if we wanted to, right? We could be, maybe we want the ninja to also have another thing, you know, like throw ninja star or something. We can give them extra methods, and we can also slightly change how it works compared to the base one, right? Now let's make a wizard as well, another classic. Okay. Now I want my wizard to be able to cast spells, right? Because otherwise he's not that much of a wizard. But maybe I want different wizards to cast different spells, okay? So what I would want is I would actually want to, when I make my wizard, right? I don't want to just give him a name. I want to tell him what spell he can use. Okay? So we're going to actually, this time we're going to override the init method. Because what we want is we want to give extra information when we create our wizard, okay? So, well, what are we going to do here? We want a wizard to still be a player though, right? So we want him to get a name, and we could always just write out the same bit of code again, and then, you know, add his spell as a self variable, right? So we store it. But in slightly more complicated examples, right? Maybe player's init method gets a bit more complex, right? Maybe player has 2 or 3 things it needs to do, or maybe down the line, right? We come back and we go, oh damn, I need to change something in the player, and we don't want to come back to our wizard and go, oh no, I have to change the exact same code twice, right? Maybe we have 4 or 5 classes that are doing this. We don't have to change it in every single bit. So what a better idea is if we want to make a wizard, right? We can start by making a player, and then by giving him the spell. Okay. So since wizard is a subclass of player, we call player the superclass. So wizard is the subclass and player is the superclass. So what we can do is we can reference player by using the keyword super, or the key function super with the little brackets there. Now what this does is this basically makes a player like this, right? So we've now got a sort of reference to player. And what do we want to do? Well, we want to make a player, so we want to call its init method. Okay? Now, something to note about super. Super implicitly passes self through. So even though we need to make a player, we don't need to pass self through now, right? Because we've sort of already done that here. And super passes self. So I'll write an example up in a little bit, but at the moment we can see that this here is making a player, because player is the superclass. And what do we need to make a player? Well, we need their name. So we call it with name. So since player is the superclass, you can think of this line here as identical to this line. So player._init. I've left out my little brackets there, whoops. I mean, not brackets, underscores. So player.init, right? This makes a player, and then we're telling it we need to pass through the self and the name. Okay? So since super... this would actually work anywhere, by the way. This isn't necessarily something that you could call in a subclass. You could call this any way you want, because we're explicitly referencing player and telling it this is the thing I'm passing in and this is the name. Okay? But since this is a subclass, we might as well use these. The better way of doing it is to use super. because it's basically saying, oh, cool, go up to my superclass, pass in self, and then just call the method like this. Okay, and just to have a quick glance at what's going on here. More names. Oh god, Bill. Bill is here's a little one. Bill is a wizard. Aha, we finally reached the meme. So Bill is a wizard. Oh, I should have used Harry. Oh well, next time. Okay, so Bill's a wizard, and his name is Bill. Right? Now, if we were making a player, we could do this, right? But no. Python's telling us we're missing one required positional argument spell, because it's not calling the player anymore, it's calling the wizard init method. So we'll give them a spell. Lightning bolt. Okay, and we can see that Bill has lightning bolt in as a spell. So let's just finish this off. Cast spell, self monster, semicolon, and let's print casts spell on monster. Okay. And now if we go build.cast spell on beastie. Oh no, what have I done? Name spell is not defined. Ah, I've done the classic class error here. We want our self._spell because the actual spell variable only exists over here. Let's try running that again. Make our wizard cast a spell. Bill casts lightning bolt on beastie. There we go. But so we can still see that we sort of basically just built up on our existing class. So Bill is still able to attack the beastie, right? Bill is still a player. Bill still has access to these classes. I mean, to these methods here, right? He's overwritten this method in his init, and he's added his own cast spell method, right? But it's still a player, and a player is still an object, right? So wizard is still technically an object if you keep working your way up the chain. The main things to take away from this are basically the usage of super, and then these concepts here. So we can add a method, we can override a method, and we can call super to basically get access to our super class if we need it. Okay, so that was actually a fairly lengthy introduction to inheritance, or basically just extending classes in general. So let's actually have a look at what the tutorial is this week. In last week's tutorial, we wrote a student class which aims to store, retrieve, whatever. The file week 8 contains a much simpler model of a student. It includes some other stuff. So let's get that up and have a look at what's in here. Copyright, whatever. So we've got a student. It's get name. It's got a student number. It can roll in courses, and it can calculate fees based on how many courses there are in here. Looks like. Okay, so pretty much what we did last week. We would like to extend this model to allow for students who live in college. Okay, cool. So a college student is still a student, right? So we just want to add a bit of extra stuff. So we're going to extend the student class to college student. Write a class college student, which inherits from student, inherits and implements the following functionality. We want to take 2 extra arguments, the student's college and their college fee. And we want to add a method get college and calculate fees, which, okay, accounts for additional fees. Let's just go down here. So we want to make a subclass. So class college student. Now here, it's inheriting from student. So we chuck the superclass student in there. Okay. Now what do we want? We want the constructor to take an extra 2 arguments. Okay. So straight away we know we're going to have to override our init or constructor method. So a regular student took a name and a student number. Now we also want them to take a college and a college fee. So we come down here and we go, well, when we make a student, right, we're still going to have to, a college student, we're still going to have to make them with a student num. And what was the other thing again? Oh, name and student num. And we're still going to need that self guy in there, right? So we still need these 2 things in there when we make our college student, right? We couldn't just omit these guys and then put in the two new things, right? Because then it's not gonna know what its name and its student number, right? And the point of this is to add additional functionality, right? Not to change everything. So what's the extra stuff we're adding? We're gonna add the name of the student's college and their college fee. Cool. Now, what do we want to do with our student, right? We want to, when we make them, sorry, our college student, we want to make a student and then give them some extra stuff. So we could come up here. We could go into the student init, copy paste, come in here and go, cool. We've done our name and our student number and our enrollments initialization. We could do that, right? This would be pretty bad practice though. For one, copy pasting large chunks of code in general probably means you could do it better. But also, if we ever go back and we want to change the implementation of student, right? So we ever want to change what's in here, we would have to come back here and change it as well, right? And for every class that's extending or inheriting from student. So a better idea is to just go, well, let's just make a student first and then customize them a bit more, give them some extra stuff. So we want to use the super class. So again, super in the brackets, and we want to make another student, right? Name, student number. Okay, now remember when we're using super, don't have to pass through self. Calling super automatically passes self through for you. And remember, when we're making a student, we need name and student number. So these are the two parameters we're passing in. So at this point here, can't type. We've made a student, right? But we want to extend off that. We've got the college student. We also want to add in their student number, sorry, their college and their college fee. So let's just store those guys inside our college object. Cool. Awesome. What's it talking about? What else do we have to do here? Write a class, add a method, get college, which returns the name of the student's college. So let's do that. Get college, still passing in self as always. And this one's pretty straightforward. We just want to return the name of our college, which we stored up here as self._college. So that's good. The calculate fees method of a college student should return the sum of all their tuition fees plus their college fee. So they've got this college fee here, right? But a student also has this fee based on how many courses they're enrolled in. Okay, so what we want to do is we want to overwrite this method for a college student, because they're gonna have different fees, right? A generic student just has only their enrolled course fees, whereas a college student has their enrolled course fees and their college fee. So let's come down here, and what do we want to do, right? We want to return the sum of all their tuition fees and their college fee. So how do we get the sum of all their tuition fees? Well, that's this guy here, right? That's what our students' normal fees are. So in a similar way to how we got super to get the constructor out, we can actually call super dot calculate fees. Okay, and this is basically saying, well, I want to go up to the student class and I want to call its calculate fees. Okay. And so we get that out, and that gives us all the enrollment fees, right? It goes through, it runs this code for us. And by using super, we've done it a bit more cleverly, right? Because if we ever go back and change this code, we'll still have access to it later. So this was our tuition. How do you spell tuition? Tuition fees. Oh, geez. And we also want to, well, what do we want to add? We want to add our tuition fees and our college fee. Okay, so we want our tuition fees, cannot type, plus our college fee, right? Which, no, self._fee. There we go, right? Because we need to remember that we stored it inside our student over here. Okay, cool. Let's give that a bit of a run and see what we've got happening. Oops. So the constructor should take an extra 2 arguments. Where have we got? Let's copy paste some code in. Fred. Great name for a variable. So we can see Fred.getCollege. Cool. So there's our extra college method we got. Let's calculate his fees. 18,000. Now, at the moment, that's what we passed in as our college fee, right? So at the moment, it's calculating the fees from all his enrolled courses, which is 0 because he's enrolled in 0 courses. And then it's adding that college fee at the end. Now, we don't really know if this is working yet because we haven't tried enrolling in any courses. So let's enroll in CSSE1001. And let's enroll in something more realistic. Cool. And we've added our fees for those. So now when we call fred.calculate fees, we should get 18,000 plus 2,300, and we get 20,300. Awesome. So just to sort of reiterate what was happening there, when we called the calculate fees and we had these enrolled courses, it went down here and it went, cool, calculate fees, super.calculate fees, right? Remember, we don't have to pass in self, as I've been saying over and over again. So it came up here and it went, cool, calculate fees. It went, well, what are the courses I'm enrolled in? Add the fee inside that and then return that total. So we already called these enroll methods. Now we're able to call these enroll methods because Fred is a college student, which is a type of student. So he still has this dot enroll, right? He also still has this dot get name, dot get student number, all that, right? But he's got this dot enroll for the moment. That's the one we care about. So we know that we were able to set up these objects inside Fred. And so later when we came down to call calculate fees, when we call super.calculate fees, we're still able to get access to all this stuff through the power of inheritance. Okay, sweet. That went pretty smoothly. Since the first section's done, I'm actually going to end the video here, try and keep the videos a bit shorter, and I'm going to split this up into 2 parts. And next up, we'll look at this web crawling, because this is a slightly there's some new concepts in here that you don't really need to worry about too much, but it's probably just going to take a bit of explaining. So I'm actually going to split up the 2 videos here. As always, if you've got any questions, chuck them down in the comments below or post on Piazza or anything, and I will see you guys in part 2.